welcome back to another live stream of how to use Semiotic, a data visualization library that uses React and D3 with me, Elijah. I'm the creator of Semiotic, the author of D3.js in Action. I guess I should try to advertise my book from time to time. Got a new second edition out in case you need to know how to use D3. Comes in handy in a lot of different places. A lot of the functionality in Semiotic expects you to understand sort of D3 data structures if you want to do advanced work, if you want to sort of step into some of the data visualization modes and replace some mark with some custom mark that you want. A lot of the API underneath matches up with D3's API. And that's because D3 is sort of the de facto standard for data visualization with JavaScript. Clicking around a lot of different views. So today I wanted to cover just a lot of sort of loose end, how to use different things in Semiotic. One of the major things I wanted to touch on was this idea of render modes and how you might use textures or gradients in your data visualization. So I want to get into that a little bit. There's some new features that just came out this morning with 1.7.4 and just some new features generally that are showing up that should prove useful in a lot of different places. This is some documentation that doesn't exist on the live interactive documentation yet. I'm in the middle of writing it, trying to explain to you how to use gradients and patterns and things like that. I just wanted to show it off because it's some of the stuff that hopefully we'll be able to get into, dealing with this sketchy and painty render modes in Semiotic, and also this idea of canvas post-processing and just rendering things to canvas more generally when you might want to use that, how you can use it, and what its limitations are. So as far as new features, there's a fix that was related to a bug report that showed up on GitHub that if you tried to do painty rendering and you tried to do it with a gradient, then it would come back and it wouldn't recognize that. And so now actually it does that just fine. For those of you who really have already dived deep into Semiotic, this is kind of a cool feature. For those of you who haven't, just know that the reason why this bar chart looks so weird and funky is because it's both using a different rendering mode, this painty rendering mode, but also a gradient underneath. So anyway, we might get as far as that. I kind of assume we won't. The other thing that's new is that in XY frame you had annotations that could be relative to the position of a point on a line. So rather than annotating a particular value in your XY chart, you would instead annotate this line on this day, which makes more sense as far as annotations go. So in keeping with that, 1.7.4 introduces for ordinal frame a piece ID accessor, which just indicates if you're going to try to use ID-based annotations, well, what is the ID that you'll be using? And then if you have that enabled, if you have some value set here, then in your annotations, instead of just sending values, you can also send an annotation like this, right? So this annotation, I've got this sort of dumb stacked bar chart that shows Ford sales versus Jaguar sales, and it's broken down by the different kinds of models for each company. And if I wanted to annotate the bar that indicated Taurus or the bar that indicated E-type, well, that would be different depending on sort of how the bars are stacked. So I couldn't annotate the actual value on screen, right? The sort of total sales value of Taurus plus whatever happened to be underneath it. Instead, what I should be able to do is I should be able to have an annotation. Let me give a line break there, like this one. that I just give a label to. I give a type to, in this case, a React annotation, and I give it a make and a model. You'll notice there's no value here at all. There's no sales value. So this way it's simply annotating the bar that indicates torus, or the bar that indicates an E-type over here in the other stacked bar on this bar chart. So that's super useful, and it should be around. It should have been around from the beginning, and it's here. So that'll come in handy. I think there's another change that's sort of in the early days in 1.7.4. So if we go into network frame, we look at a Sankey diagram. Sankey diagrams are super useful when you're not rendering your legend right on top of it. But don't have to worry about that. I'm going to go over here into the code for Sankey diagram in the examples. And I just want to demonstrate this. I don't want to get too far into it because like I said, this is early days, but it might come in handy for those of you who are making network diagrams that have a little bit more structure. If you send a flowchart type to your network diagram, let me get rid of that legend right now. There's obviously not enough margins everywhere. If you send a flowchart type to your network type, then it'll use a Sankey diagram under the hood. But what it'll actually end up rendering out of that Sankey diagram is a more traditional sort of stick and circle node diagram, which will be more useful if you want to build out flowcharts. It's something that we're dealing with in production, and so we need to have a way of, we have these stepwise networks, but really fundamentally they're basically flowcharts. And if you take a Sankey diagram, you can actually make a flowchart out of it, but then you have to override a lot of stuff. So instead, it's got sort of just some of these overrides already built into it. And it also allows for some directions to it. So you could have your flowchart go up, and it'll render it going up, or you could have it go down, and it'll otherwise, do all the proper processing and packing and everything like that. If you use that, I'd love feedback with it if you're dealing with flowcharts. If there's a particular, right now it's using that Sankey layout underneath. If there's a particular flowchart layout algorithm, this is something I sort of dug into over the course of this week and last week, and I saw a lot of different examples of flowcharts, but nothing that was really sort of compact and really clean. So if you know of a good flowchart layout that you think could be implemented under the hood, ping me, let me know. I'd love to hear about it. As far as that bar chart annotation, I'm going to go drop that into the chat. And like I said, today I'm going to just jump through a few things. I'm going to play around with render modes and, like I said, show off some of these features and not really go too deeply into one particular area of semiotic. That said, if there's someone watching and if you have a specific question, if you want me to dig into a specific feature or show how to build out a particular kind of chart, I'd be happy to get into that with you. Just let me know. One of the things that I've heard a request for a couple of times is that I do a live stream that shows how to build an actual sort of large-scale dashboard that shows how the different charts would interact with each other and how they could update if we change the data in the back, and how you might wire up a UI, how you might deal with state or Redux and things like that in React. So that's my plan for next week's live stream. Is I'm going to just find a really nice data set and try to build a dashboard that looks into that data set, that deals with things like brushing, having different kinds of charts, how you might have different kinds of charts working in tandem with each other. So with that said, I'm going to get into playing around with different kinds of things. In this case, I'm going to be looking at gradients and render modes and things like that. So This is a pretty Spartan little pen here. All it has is this British Premier League data, English Premier League, I should say. And if you joined me last time, you'll know that these different lines are suitable for rendering in a time series chart. And then if we want to, we can pull out these different lines and we can build bar charts or other kinds of things out of the particular data from say, the performance of Arsenal or any of these other teams that are represented in this data set. So let's go take a look and see what this data looks like. Let me make a change so it updates. So for instance, I've got this Arsenal data. Arsenal's one of these football teams. They've got a lot of wins, they've got a lot of losses, and other data points that we can sort of focus in on. And to begin with, what I really want to do is I really just want to show off some of these render modes. So let me take some of this data and make an XY frame out of this real quick. I'll just do a XY frame. I will render some lines. That'll help us to understand things. I don't want to deal with all of these teams. It's just so much data in here. So instead, I'll just take the Arsenal data, the Queen's Park data, and the Everton data. If I go take a look at how this looks, I think this is actually, let's see what this looks like. So these individually are going to be the arrays that make up the coordinates. So what I'll need to do is I'll need to wrap these in some kind of object that says label Arsenal coordinates, Arsenal data. If I can spell coordinates properly, and actually I'm going to pull this out because this is starting to get messy. So 3 teams, and I'll take 3 teams. I'll make that up here. So what have I got? I've got Arsenal. Their coordinates are that Arsenal data array that I just saw, and I'll give them a color. I don't think I have my color array, so let's go for categorical and give me some colors. For those of you following along at home, I'll just drop these links into the chat. Categorical, I don't know, give me 5 colors, categorical, and make them light-ish. I kind of like light colors. Even though, of course, I'm building a line chart here, so I'll probably have to turn it into an area chart since lines prefer dark colors. That's one of those things you learn about colors. Why is it always so many greens? I don't understand why categorical insists on giving greens. Okay, that looks good. It's very Easter. It's a very Easter color scheme. And again, 2 greens. I think that categorical is being paid by Big Green to put more colors into it than it should. Colors equals, and we'll const colors. We'll go colors of 0, and then we'll do the same thing with these other arrays of coordinates. Colors 1. If any of this doesn't make sense, of course, and you're following along, feel free to ask, and I'll explain what I'm doing over here. Otherwise, I think it should be pretty straightforward. So I've got this array of objects. Each of those objects is a data set that relates to the performance of a soccer team over the course of the last century. There we go. That should work. We put that in as lines. We tell those lines that, I don't remember what is it we've got here. We'll plot year on the x-axis, and we will plot wins on the y-axis. So the x-successor then is year. The y-successor is wins. Is that what? Wins W. Capital W. Wow, what a bunch of things. W, line type, stacked area, line style. That looks like we've got an outlier. Remember, line style can take an object, or it can take a function that returns an object. That object is a react style object. So I can tell it to get the fill from the parent fill. And there's my lovely little chart somewhere down there. We'll change the size of it. And I'm really just doing this to get some sense of the data at least, then we can dive into it. So there's some year, apparently, when everybody won. When everybody won. So I don't know what this is. So I'll turn on hover annotation. You know, it's funny, Semiotic's not actually built for exploratory data analysis. You can see that it's got a lot of the same principles as exploratory data analysis. But it's not built for that. That was never the point. But you do find yourself doing that. Oh, this must be, I have no idea what this is. You'd think I'd looked at this data enough that I would finally start to understand it. Orient left, make some axes, right? So that we can actually tell what these numbers are at a glance. So that's kind of like a principle of data visualization or something. And there we go. So in 1984, apparently, there was a lot of winning going on. Margin. Just give a little bit of a margin so it doesn't feel like it's cut off. Once you do that, though, it overwrites the smart margins for when you've turned on your axes. So there we go. Okay, so now I've got my data set. Now we know how this data set works under the hood. We know that there's like gaps in the data and things like that. So what I'll do is I'll take the actual original, I'll just set up a line data accessor that says give me back d dot coordinates filter where d dot year is greater than 1980. Nothing happened before 1980, right? D dot year. There we go. So now we're only looking at since 1980. We still have that big spike, but we don't have a bunch of weird sort of, you know, back in the 1800s and whatever, where this data set has a lot of gaps. Instead, we you know, are properly encoding how the Queen's Park Rangers aren't even in the league during a lot of this period. If you followed me in some of these earlier ones, I was always mocking Everton, but it turned out Everton was actually a pretty decent team in comparison to the Queen's Park Rangers, which is to say that the Queen's Park Rangers must be some kind of junior varsity team because Everton's the worst team. And here we go. And I can go and take a look at this, and I can see these numbers and have some nice colors. They actually turned out to be very nice colors. Good job this time, Color Corporal. So we can get started here. Let's get started here. Line render mode equals sketchy. Now let's think about what this means. If you want to, you can render your shapes in this sketchy manner or this painting manner. These are what the render modes are. I've touched on them a bit. They show up throughout the site. I just wanted to sort of explain them. You can see that it in rendering in both of these modes, that it's still doing it in a way that's going to slightly damage your ability for your readers to evaluate the numerical values of these charts. So keep that in mind. I mean, that's what's going to happen. Oh, isn't that interesting? Actually, what this is doing, Sketchy seems to be actually making a complete, okay. So for some reason, Painty doesn't seem to like that block there where Everton has 0. So I'll dig into that later, and I'll only deal with the Painty rendering when it comes to bar chart. So let's go and make a bar chart. Let's go make a bar chart of, I don't know, it looks like 1992 was a good year. So let's go find out what happened in 1992. And how would we do that? We can take Premier Lines, const Premier Lines equals, let's see, stats 1992 equals Premier Lines, which if you'll remember is an array where each item in the array is a team. I guess it's not going to show me that one. Here. Each item in the array is a team. Each team has a set of coordinates. If we go into those coordinates, we can then only get back 1992. So Premier Lines dot map will return an object, and that object will have a label equal to the name of the team, right? So d.team, and then it'll have a value equal to d.coordinates find the object where the year equals 1992 and get its what? Actually, we'll just get it. Which begs the question, right? Why even create an object out of this? Instead, we'll just get that. That seems much cleaner. Much cleaner. Great. And let's go see what that gives us. Stats 1992 has 69 items, right? Corresponding to 69 items in Premier Lines. And wait a minute. That's Arsenal data. I was going to say that did not look like what it was supposed to look like. Where's my stats? Stats 1992. The one thing about CodePen keeps refreshing things, and sometimes you don't know when it's actually told you something, or when it's overwritten the array that it was showing you. So here we go, great. So in 1992, you'll notice that there's a lot of teams, of course, that weren't in the league during that year, which is great. It's actually exactly what we wanted. I don't know why all of them have the same p-value. I wonder what that p-value is. I suppose that corresponds to some kind of, whatever year it is. That's all I can imagine. So anyway, so what we're going to want to do, of course, we're going to want to say, well, stats1992.filter only give me back items that have, what was it, a team, right? Because otherwise they're just sort of fillers for when we're making line charts. And now when we look at stats 1992, and this is just data processing, like I try to say, there's nothing about semiotic that's going on here. I'm just trying to get an array of data. I'm just trying to transform this array of data and take a sort of slice out of it. So now I'm looking at 1992. I've got all these teams. I've got their ranking. I've got their wins, and I can put that on a bar chart. So let's go drop an ordinal frame in here. Data equals stats 1992, type equals bar, we're going to split them by team, and then we're going to rank them by number of wins. Probably seems rather silly because it'll probably be just sort of oh wow, somebody had no wins at all. That's so sad. Give them a style. Let's go see what happens with a pink fill and a green stroke. Isn't that lovely? Isn't that just beautiful? Probably not. So, give it a little padding. Change the size so it's shorter, so it suits our aspect ratio. Something that's interested me quite a bit lately is the idea of what charts are optimized for what aspect ratios. And I can give it an axis, why not? That's fine. I'm not actually honestly very concerned about who these teams are. I just want my chart to look kind of like a chart before I start making a mess out of it. Okay, so there we go. Little bar chart. And again, we can do the same thing over here that we were doing with the XY frame. And if I say sketchy render, then sure enough, it does a sketchy rendering. And you'll notice it even draws the little line around the 0 value here because it's actually drawing a path. It's drawing a path that's surrounding your sketchy fill. And so when it's a rectangle, that rectangle has a height of 0 and it's not rendered. But when it's a sketchy rectangle, it's a path, and so it actually gets its little surrounding stroke rendered. And likewise, sketchy, we can say painty. And one of the things I wanted to get in here is I could say that, and you'll notice the painty is, also draws the little border outline, which can help with the damaging effects that painty does. Render mode also will take a function that returns one of those strings, right? So I could say d.w is greater than 10 and return sketchy, otherwise painty. And if you just return undefined, then, hey, wait a minute. d.w greater than 10. Let's go see what. As usual. Oh, wait. There's only. Looks like it only goes up to 10 wins. So I just don't really seriously comprehend how. Honestly, don't know how this stuff works. Soccer, not data visualization, fortunately. So there we go. So now we're looking at a particular render mode if you've passed a particular threshold. Now, this isn't typically what you'll want to do with this kind of render mode, right? You'll want to say something like, if you know that something is certain, then you'll want to render it normally, and then maybe you'll want to render uncertain things using sketchy rendering. So it could be that if we imagine that this data set represents a different data set, and I'll try to dig up a different data set because I know that always makes it easier to learn things, as if the data set actually matches with what you're trying to express. But if you had some data set and you were getting sample data, right, from some kind of sensor or something, and you knew that some of the sensors that you had were audited and some of them weren't, then you could use render modes like this to say, show the unaudited, or the things that are not passing a statistical significance value, or so on and so forth, with a sketchy rendering instead of a sharp, what they call photorealistic rendering. So that's why that functionality is in here, is that there are times when you want to do this, and if there are times that you want to do this, then there's going to be times that you want it to be data-driven. I'm not so sure. The painty rendering, I just sort of put in there. I think that I'm not sure when you would want to alternate between the painty and the sharp. But the sketchy is actually researched. It's it's not well researched. There's a few papers on it, and it does seem to have real value. And I think that intuitively you can sense why when you see it. So that's render modes. Render modes are one aspect of different ways that we can make these shapes appear differently on the chart. Another way of doing that is to actually use the built-in SVG functionality to define gradients and to define patterns and use those as fills. Now I'm going to go and cheat a little bit. I'm going to go grab a pattern that I've already got defined for that example page that I was showing you. Because we're working in JSX, it's pretty straightforward. You just make what you would think of as an SVG gradient. And you assign it to a variable. So here we have a gradient. We're defining it as a vertical gradient. It's got some kind of ID. That can be whatever you want. It just has to be an ID that we're going to reference later on. It has a number of stops in it. This one has 2 stops. You can define multiple stops. Stops can encode opacity, so transparency, and it'll just naturally draw the gradient from each stop to the next. Now the challenge with something like Semiotic is how do I get access to that gradient? Because normally what I would do with my fill is I would say something like URL gradient. I'm trying to remember, is it that? I think it's that. And you'll notice that, of course, it doesn't know what to do to draw this, because you're referring to this gradient. Let me go make sure again. Go make sure. Oh, okay. So there's no quotes. That's what I thought that was wrong. So you refer to this URL, and in this case, the URL is a local one, right? I'm just using this ID. And it doesn't find it because that gradient, even though I've declared it up here, it doesn't exist within the DOM where this chart is being drawn. And so what you need to do is you actually need to pass it into the defs, the definitions of your SVG, the actual SVG where the drawing is being done. And the way that you do that with frames in Semiotic is that all of the frames have an additional defs property. And that additional defs property is where you would pass any sort of patterns, gradients, marker, I think they're just called markers, the little sort of arrowheads and stuff that you might put on things. So if I take this gradient and pass it to additional defs, then suddenly we're rendering with that gradient. And I want to make this not mysterious for you. So remember, I defined that gradient as a HTML or JSX, however you want to look at it. And then if I go in and look at the SVG, if I go down into the tree, Semiotic's got there's a lot of layers to it. But at the very bottom of it, in the visualization layer, is an SVG canvas. And in that SVG canvas, I've got all the elements that I'm drawing, sure. I've also got these defs. And it comes with a couple of defs. This is how Painty works, is it uses some filters, much more complicated filters, SVG filters, than this simple gradient. And you can pass filters, and you can use filters in the same way that you might. So you've got this Gaussian blur and color matrix, and you could do displacements and all sorts of stuff. So you can pass filters using additional defs, and then you could reference those filters later on. In this case, we've just passed a linear gradient, and here it is, available to be referenced by anything that lives within this tree, right? Actually, I think that's not correct. I think I could actually now reference this from a different SVG. I'll bet you I can. Let's go see. Let's go find out, Phil. Yeah, that's right. Anywhere on the page because it's a URL. So now I'm filling these with a gradient. And I think they'd look better if they weren't sketchy. Yeah, look at that. Looks beautiful, like some kind of Smoky Mountains. In fact, I'm going to go find some Smoky Mountains. So here we go. The only reason why you guys come here is to find out the secret resources that I use to do amazing things. Here, there's a uigradients.com. It just has these most beautiful gradients. I didn't find this either. This was revealed to me by Rachel Binks. And it just has some of the most beautiful gradients. And what I want to do is I want to find a gradient that makes me think of mountains, misty mountains. And then this gradient, you just pass these gradient values to your gradient. So let's go with, make a new one, say, mountains. What am I doing? This is not where I'm supposed to be. I got so caught up, I got so excited about all of this that I thought I just went back to an actual, I'm going to make a data visualization mode. So instead of gradient over here, we're going to do mountains. I'm going to go get this color. I'm going to get this other color. And that's what I'm going to reference in my line chart. I feel like that would look terrible. It didn't work at all. What's going on? Oh, right. Of course it didn't work because now what am I referencing? I'm referencing a gradient that doesn't exist anywhere in the document. And that's why, even though you could reference cross-document, you could store it in one frame, it's probably always best to make sure to pass it into the additional defs of the frame where you're rendering it. Additional defs, mountains. And there we go. It's not the direction I wanted it to go. I knew that that was going to happen somehow. There we go. That's exactly what I want. Now, is this necessarily am I teaching you superior data visualization techniques here? Well, yes and no. So, is this going to help somebody to understand this? No, because now I've suddenly lost my colors. And I wouldn't be able to differentiate between Everton, Arsenal, and Queen's Park Rangers. So in that regard, this would be bad. So I wouldn't suggest that you just use a single gradient to pass across all of these. But what I have noticed is that if you use gradients in like slight gradients to distinguish between, say, pieces that border each other, like pieces of a stacked bar chart, or individual areas in a stacked area chart, then those can help to differentiate in a way that if you're using labeling and you're using other sort of annotations and enclosure rules, then that can actually be superior to the sort of traditional blue, orange, green color scheme with a legend over on the side. So that's how you would use gradients. I'm going to go now and grab a pattern from my examples. Patterns are harder because, like, you want to use nice patterns. You don't want to use terrible patterns. And most patterns, unless you start to think about them, they get terrible very fast. It's the same kind of thing that you would do, though. You sit here and you pass a pattern like triangle pattern, and then you can pass that pattern into additional defs. So maybe we want to pass patterns and gradients. Oops, triangle pattern. But then, or not but, so here in our bar chart, you can sit here and say, it's the same kind of way of telling it to fill, right? You just pass it the URL of the pattern. So let's say I is less than 10, that, otherwise, I think it's called pound triangle. And there we go. It was called pound triangle because originally I got some triangle. It had triangles on it, and it looked terrible. And naturally, it always looks terrible. This is like this offset circle, this offset clipped circle that I thought looked like alligator skin. And what you'll notice here is that just like with the gradient, the sketchy rendering is still obeying the gradient or the non-solid fill that's been passed to it. So that'll happen, and really, if we want to get into Painty, the same thing will happen with Painty. Got a weird notification from YouTube saying that they were not receiving data, so maybe my stream quality went down for a second, but it seems to be good now. So again, there is some reasonable rhetorical value, and you can sort of see it, like I said, intuitively. When you have an intuition, when you look at a chart and you have some kind of intuitive sense of something, then that's a good indication that something's going on with your visual cognition. And so when you see that this sketchy implies that something maybe is older, or it's less sure, or just somehow uncertain, then you should embrace that. You should try to find out where that works with the data visualization that you're using. Because that's the only way that we sort of find out how things work, is we try them out. One of the reasons why I tried to enable this kind of stuff in Semiotic was to enable more people to try this kind of thing out. So hopefully you'll go out and do better work with that. Now, there's an entire, there's this great library called Textures.js that came out a long time ago that allowed you to easily create textures that are more suitable for data visualization and cartography. And then Textures.js was ported in a React kind of way over to VX Pattern. And so VX Pattern gives you an interface that allows you to create a bunch of these same patterns that are suitable. I'm dropping this into the chat. Suitable for data visualization. SVG patterns, you can create whatever pattern you want using shapes. And that seems great until you realize that that's not what you want. What you want is some patterns that don't make your eyes bleed when you fill them into a bar chart. So that's what's available in Textures.js. That's what's available in this VX pattern, and that's what I'm demonstrating in one of these examples. I go back up to this interactive documentation that'll be coming out. Here's a VX pattern example. I'm not going to be able to show this to you easily on CodePen, unfortunately, though, because CodePen doesn't give me a good way to import VX pattern and then run through it. So just know that that's also available to you. VX pattern produces the same kind of thing that you could just drop into your additional defs anywhere and then reference. So you can do pattern fills and do nice wavy pattern fills or horizontal lines or diagonal lines and so on. The last thing that I want to touch on is another little piece of functionality that all of these frames have, which is that they will do canvas rendering for you. So if I go into here, and now they won't do canvas rendering with any of these fancy fills, unfortunately. So go back to my, or I'll make a new one because I kind of want to keep that. I have to keep it for screenshots, right? I have to keep it for social media currency. So line style, we go back to what we were doing, which is we do d.color, and that should give us our chart. Yeah, great. Now we've got this chart, it's being colored, and what you can do is you can actually set the frame to tell, you can tell the frame, render these with canvas. So now it's rendering these in canvas. And we want to ensure that canvas is rendering them exactly like we want. The one thing you should remember with canvas rendering in Semiotic is to make sure to send an explicit stroke color. So in this case, it was assuming that we wanted a stroke color of black when we wanted to have the same stroke color. You'll notice that even though, so if you'll see that the axis is now being rendered on top because the canvas layer is underneath. If we go and inspect this, you'll see a bunch of paths. We'll get back to that later. That's actually something I want to get into. The SVG only has axis elements, and that the actual data visualization is being drawn to this canvas layer, which means I could go and delete this canvas layer and you see that it disappears. That's useful in larger scale applications because what it allows you to do is it allows you to reduce the number of elements being that are in your DOM tree, and so that can be helpful in improving performance. And in Semiotic, because the interaction is based on a completely different layer, then you still have interactivity even though you're rendering canvas, because the interactivity is happening in this interaction layer on top of it. Now that's available. Like I said, it won't render the gradients. Canvas does do gradients, but I haven't gone in and tried to figure out how to translate the SVG way of drawing gradients with the canvas way of drawing gradients. It will draw them for your lines, your areas, and your points. It will draw them for your simple nodes and simple edges in the network frame, and it will draw them for all of the simple types that are in your ordinal frame. Canvas rendering does not currently support rendering the summary types in ordinal frame. So there is no, there is no summary, canvas summaries yet. Those can only be drawn in SVG. So I'm going to stop there. That's covered a lot of these rendering techniques and functionality, how you can use sketchy rendering, painty rendering if you want, if you're feeling more playful, how you can use gradients, and how you can combine those to create sort of aesthetically pleasing, but also I think valuable for information and communication in certain circumstances. Data visualization products. Thanks for joining me, and next week, like I said, I'll get into building out an entire data dashboard using Semiotic and tips and techniques for making that successful.